How you doing on this windy night? Boy, it's just howling out here.
Yeah, it's pretty annoying. But I'm doing good. How about you?
Good.
All right. So I have another test tomorrow on kind of quadratics again.
Okay.
We're taking a long time on this subject. I don't know if that's normal, but
Well.
I guess just because there's a lot in it.
But
it's really just the second half. So if we could go over, there's 4 topics: imaginary numbers, quadratic formula, word problems, and the discriminant.
Okay.
You said that those are going to be the main things on the test, like the second half, but we're still going to need to know vertex form, completing the square, and factoring.
Okay.
So if we could go over the last 4, and then if we have time, we can do the top 3, just kind of review them again.
That's the discriminant.
Yeah.
The part that is under the radical sign in the quadratic formula is the discriminant. Why does it have its own name? Because if you take a quadratic and you analyze this as the first step, you can tell a lot about your solutions, whether they're going to be real or imaginary. If this thing is positive, they're going to be real. If it's negative, they're going to be imaginary. And if it's precisely equal to 0, there will be only one solution. That's also the vertex, the line of symmetry for the vertex of a quadratic. Minus b over 2a. Imaginary numbers.
Wait. So with the discriminant, can we do a problem or?
Oh, sure. Do you have one? Just pick a quadratic and we'll examine its discriminant. I can make one up if you like.
Yeah, that'd probably be best. I don't know if I have one handy.
So if someone gave you this and said factor it or solve for x, let's make it an equation, so we're going to solve for x. Well, it might be worth knowing what the discriminant was as your first thing. So let's solve. What is b squared? Let's take away the radical sign because the discriminant is what's inside.
Okay.
So b is what?
So 25x, or negative 25.
Well,
no,
it's actually negative 5 squared, which is 25.
Okay.
Minus.
But, so you don't add the x, you just.
No.
Okay.
When you're doing the quadratic formula, the a, b, and c are the coefficients. That's a,
okay.
That's b, and that's c. Actually, that's not quite accurate. A is 7, b is minus 5, and c is plus 10.
Okay.
Okay. So minus 4 times a.
So 7 times 10, so 70.
Okay.
So 4 times 70.
So we can see right off that that is a bigger number than that, which gives us a negative discriminant, and we're going to have imaginary numbers.
Okay. Oh, okay, yeah.
In other words, yeah, that's 280, so we have 25 minus 280. So
let's see. So wait, if the discriminant is bigger than 0, then it has 2 real answers.
Correct.
And if the discriminant is equal to 0, it has 1 real answer.
Correct.
And if it is smaller than 0, it has 2 imaginaries. Okay, so.
Yes. Let's go ahead and solve this.
Wait, so what is the
discriminant? Solve this using the quadratic, because we'll deal with imaginary numbers at the same time.
Okay.
So let's see, what is that? 25 minus 280, that sounds like minus 255. Okay, so our answer is, what's minus b?
B is 5, so.
So what's minus b?
-5.
No, b is minus 5.
Oh, so then it's just 5?
Uh-huh.
Okay.
Plus or minus the square root of minus 255 all over 14. So here's our answer. Now let's see how to simplify that.
Wait, now, hold on. What happened to the 25? Or,
Took 25 minus 280 to get this
oh,
minus
okay, never mind,
255.
yeah.
In other words, the discriminant was minus 255.
Okay.
Okay. So now, let's see, I just made these numbers up. 255. I don't know if that simplifies or not. Let's assume it does not. It's not divisible by 25. It's not divisible by 4 or 9. Is it divisible by 9? No. Well, hold on. Maybe it is. 18, no. Okay, so how am I going to write this in proper format? Proper format being A plus BI. So what's the A? Well, let's talk about imaginary numbers before we tackle something quite this hard.
Okay.
Let's talk about, what is this? Equal to.
That is 4, square root of 4 times the square root of I.
Not quite. You're close. In other words, that is the way to do these. The way to do these is to separate it into that and that. In other words, 4 times minus 1 is minus 4, so you can always do this. And then the square root of 4 is 2, and that is I. So the square root of minus 4 is equal to 2I.
So wait, so I equals the square root of -1, right?
Yes. Yes.
Okay.
So if you always take this and separate it into the square root of -1 times the positive square root of the number, it becomes very easy. So let's handle that 255, that minus 255. So what's that going to be equal to?
250, the square root of 255 times the square root of -1.
The only thing you have to be a little bit careful about is not to carry your radical sign and include the I in it. This is the coefficient of I. Okay? So, if we're going to put this in A plus BI format, this is the A part, that's the B part, or the BI part. So this number that we came up with here is going to be 5/14, the A, the real part, plus or minus 255 over 14I. So here's A, here's B, in official complex number format. You've learned this A plus BI, right?
Yeah.
Okay.
And that's the one where you always need to have plus or minus, right?
Well, you you're going to always get a plus or minus unless the discriminant is 0, and then the plus or minus has no effect. So, yeah, you're always going to have a plus and a minus. So that there's one answer, there's the other answer. For x, x would equal those two. In other words, when we plug this in to the quadratic formula, it is x equals minus b plus or minus square root of the discriminant all divided by 2a.
And it'll come out with the same answer?
That's how I got the answer I got.
Okay.
Was by plugging.
So the discriminant is basically just like a faster process.
No, the discriminant doesn't really solve for x. It just solves for the discriminant. If you're going to have to use the quadratic formula to solve, then there's no real need to examine the discriminant. Just go ahead and do it.
Okay.
But sometimes...
But it seemed to skip something. Or actually, I guess it didn't.
No, sometimes the teacher will make up a problem saying, does this quadratic have real solutions or imaginary solutions? And you don't have to actually solve it to answer that question, as all you have to do is examine the discriminant. So it can frequently be useful to know whether you're dealing with... Notice that a quadratic that has imaginary solutions does not have any y-intercepts. Excuse me, does not have x-intercepts. If a parabola or quadratic has x-intercepts, then these are real solutions. There's two real solutions. So that's something that's helpful to know, is that if you have nothing but imaginary solutions, you don't have any x-intercepts.
Okay, yeah. Okay.
So, let's see. Okay, yeah. What else do we need to cover here?
And then, let's see. Can we do a couple more imaginary numbers? Like just a couple more problems.
Yeah, here's something they may want you to know. What's I squared equal?
Isn't it just 1? Or something?
In other words, when I take the square root of anything times the square root of that same thing, it's always whatever's inside there. So when I multiply square root of -1 by square root of -1, I'm going to get -1.
Okay. And then
Hold on, yeah, because we go up to the fourths. In other words, it repeats after you get past the fourth power. What's I cubed equal to?
Let me double check. I cubed is -I.
Because it's -1 times I. That's why.
Okay.
And then I to the fourth?
Is 1.
Because it's I squared times I squared. Now, I to the fifth is just I. And I to the sixth is I squared. And I to the seventh is I cubed. So what is I to the 501st power equal to?
I don't get how you would go all the way up there.
Well, notice it repeats every 4.
Yep.
So I to the ninth, I to the ninth is going to be I. So what would I to the 24th be?
Well, I don't get how you skip. It's like a pattern thing, isn't it?
Yeah, it's
I don't get how you solve that pattern.
Okay, well, Notice that I to the fifth is I to the fourth times I. And I to the fourth is 1. So I to the fifth is just going to be I again.
Uh-huh.
And then I to the sixth is going to be I to the fourth. In other words, I to the sixth is equal to I to the fourth times I squared. And this is always 1. So any I that is a multiple of 4 is 1. So when I said, what is I to the 24th? Well, that's a perfect multiple of 4, so that has to be 1.
Oh, okay.
What is I to the 500th power?
It's just I.
It's 1. I to the 501st power is I. I unintentionally fooled you because I said what was I to the 500th.
Oh.
So I to the 500th is the same as I to the 4th. In other words, 500 is perfectly divisible by 4. So I to the 501st power would be I. I to the 502nd power would be I squared, or minus 1. In other words, once you memorize these 4, it repeats every 4.
Okay.
So you have to take your exponent, divide it by 4, and whatever the remainder is. In other words, to figure out what I to the 6th is, divide 6 by 4. It's a remainder of 2. Well, that's what it's equal to then. It's I squared. So as long as you
divide
memorize
any number by 4?
any exponent of I, not
Right.
any number, but when we're talking about imaginary
Right.
numbers. Yeah, in other words, if I say, what is I to the 78th power? Well, I divide 78 by 4, and I get 19 with a remainder of 2. The remainder is what that's equal to, I squared,
Okay.
which is equal to minus 1. In other words, you need to memorize what's in the box. But anything other than what's in the box can always be figured out by just dividing whatever your exponent is by 4 and working with the remainder. If the remainder is 0, then your answer is 1.
Okay.
Okay?
Mm-hmm.
All right.
So can we do a couple problems just to, like the first one we did?
Yeah. What do we want to do with these problems? Take the quadratic and factor it? Or solve it?
Just some more imaginaries.
Okay. So let me.
Because I know that she's definitely said we're gonna have like, you know, a couple of them on the first page. So.
Uh-huh. Okay, let me find some complex quadratics. 270. Okay. See, my problem when I have to come up with the problems is I never know precisely the degree of difficulty that you're dealing with.
Yeah.
You can have high degree of difficulty, you can have low degree of difficulty.
I can find some then. Hold on.
That's better, but this one really, I'm not sure. This one really, this is not what I wanted it to be. This doesn't have an X term in it. However,
I think I might have one.
Well, go ahead and solve this as long as I wrote it up there. You're definitely going to need to be able to solve this. How do we solve this?
Okay. 5x squared plus 18. So for this one, I would divide both sides by 5 first.
Not yet. Let's get rid of the constant here. In other words, because if you divide both sides by 5, you're going to have to divide this 18 by 5.
Okay, yeah, I get what you're saying. It'll be easier then. Okay, minus 18. Subtract 18.
Okay. Now what?
So then I would divide both sides by 5. And then x squared equals negative 15 5.
Now what?
3. And then the square root of negative 3 equals x.
Actually, x is equal to plus or minus. Remember, those should always be the first words out of your mouth. Plus or minus the square root of negative 3. So in terms of I, what is that?
In terms of I?
In other words, the square root of negative 3
Oh,
is
okay, I get what you're saying.
imaginary.
It's square root of 3, or yeah, square root of 3 times the square root of I.
No, it's not times the square root of I. It's times the square root of negative 1, which is I.
Okay.
In other words, it's very rare that you're ever
I
going to
thought
have
that's how
that.
you write it out.
You're not ever going to have the square root of I. Not in Algebra 2. Maybe in 4th year college algebra.
Oh, so then it's square root times I, isn't it then?
Okay, here's what we're going to do. We got the square root of negative 3. First of all, we're going to make that is the same as the square root of 3 times the square root of minus 1.
Okay.
Okay, so this is now the definition of I. So our answer is the square root of 3 times I.
Oh yeah, okay. That's right. I was mixing up just the step before. I kept thinking you put the I there.
But
okay.
Don't forget the plus or minus. You will definitely lose points if you do not include this plus or minus. Even with imaginary numbers, it doesn't matter. It's still plus or minus. In other words, this has two solutions. One of them is square root of 3i, and the other is minus square root of 3i.
Okay.
All right. What did you find for problems?
I think this one is a little bit more complex, but
Okay.
it is 3x squared plus 18x equals 4x plus 5.
Okay. What's our first step here?
So this one, I would want to move the 4x over to the other side.
Okay. Now what?
Now I would, I wouldn't want to square root it.
No.
I don't think yet.
No, because you have an x term. So we
Right.
can't solve it the same way we solved the previous one. The previous problem did not have an x term. It was strictly x squared and numbers. So
Okay.
when there is an x term, there's always something you have to do. And you want to recognize it immediately when you go to solve a quadratic. And that is set it all equal to 0.
Okay.
That's the step you weren't seeing.
So whenever there's,
Whenever you have
Two
an
x's
x
there.
squared and an x and a constant, when you have all three, you have a quadratic that the way to solve it is to move everything to one side and leave 0 on the other.
okay,
This is standard format.
okay, yeah,
What we were given was not standard format. This is now standard format.
okay,
Okay? Now, I could play around with trying to factor that, but might take a while. to see whether it does or not. Actually, you know what? It does factor nicely.
And then, of course, the other option would be to do the quadratic equation.
Exactly.
Or we could probably do the discriminant as well to kind of... I don't really understand the whole discriminant thing. Like, why do you even go through that process if it's just going to put you in the same spot as the quadratic equation?
Well, suppose
like
this one is pretty easy. I saw this one quite easily. It factors that way, so I don't need to use the quadratic here. My solution is x equals 1/3 and x equals -5.
Okay.
Okay, but let's say now, can you imagine trying to factor that? We have so many different factors of the number 24 that we have a ton of choices for what goes with the x, and we have a ton of choices as to what the numbers are.
Right.
I wouldn't know where to begin. However, one place that I might want to begin is figuring out whether it has real solutions or not, because if it has imaginary solutions, I know I can't factor it, and I'm going to go immediately to the quadratic. So I can check the discriminant and see whether this even has real solutions. Well, what is the discriminant? The discriminant is b squared minus 4a times c, which is a minus 24. Now I have a minus times a minus, so this whole thing is a big plus number. So I know I do have real solutions, and it might be factorable. However, I'm still going to go use the quadratic formula on it because I don't want to waste an hour trying to factor it. So I go straight into the quadratic, so it would be minus 14 plus or minus the square root of this number, whatever that number is, say 2,120 all over 48. So there's my answer.
Okay.
Okay, so that's one use of the discriminant, is to let you know whether or not you need to use the quadratic formula or whether potentially it could be factored.
Okay. And then, well, I feel like for me, because I usually struggle with remembering all the steps. I usually mix them up. So I feel like for me a good strategy would just be to try everyone, because I know that they all work with the quadratic formula.
Yes.
I mean, do you think it's all right if I just
always use the quadratic?
Yeah, I mean, obviously if they say do it this way, then I can't do it. But you know, if it doesn't say you have to do it a specific way, I mean, is
That's
it
not a bad idea. I'm pondering that idea. It depends on how fast you are at doing the quadratic. Let me give you one, and I'll see how fast you are.
Okay, I'm probably not that fast. I don't want to forget one step or something of another thing.
Do the quadratic on this for me. In other words, if you're going to use your technique, then you want to be able to do it and do it correctly and quickly, because speed is going to be a bit of a factor.
Okay, so then this would be 9. This would be minus 9 squared, or negative 9 squared.
It's always going to turn positive even if it's negative.
Okay. Minus 4 times 4 and 7.
Now, in this case, it's a positive all over what?
2a.
which is?
So 8.
Okay. Now, what's in the middle here? We have 28 times 4. That is 112. So, we've got 9 plus or minus the square root of, what did I say that was? Minus 112, so it's minus 31 all over 8. So tell me what my two answers are.
So it's
In A plus BI format. Is she ever going to force you to do that?
Yeah, I think she will. Okay, so then 9 over 8, and then plus or minus square root 31. Well, so do I need to have the imaginary for this?
Yes.
Okay, then this is
Because we have the square root of a negative number. So it's always going to be an I involved. And both solutions are going to be imaginary. There's no real solution here. So how do I state the rest of it?
So then this, you would divide, wait, what, would you 31 divide by 4?
No.
Is that how you...
No, in other words, we want that.
Oh wait, no, okay, yeah, sorry, I keep forgetting these steps. Okay, so then it's square root of 31 times 1, or the square root of negative 1.
Which is I.
Yep, which is I. So then
Over 8.
all over 8.
Make sure this fraction bar doesn't go, well, it doesn't really matter if it goes under the I. But this is now in A plus BI format. 9/8 is A. B is root 31 over 8. B is a real number, but it's the coefficient of I.
Okay.
Okay? So the answers are really 9/8 plus this I is one answer, and the other answer is 9/8 minus this times I.
All right. And if she doesn't ask for the AB format, is it just the answer
Yeah.
above?
Well, no, you still have to put in the I. It would just look a little less divided up. In other words, it would be 9 plus or minus root 31 I all over 8. In other words, that would be a sufficient answer also, but notice this is not in A plus BI format. It's close.
Okay.
All right.
Cool. I think I get that
Okay.
pretty
So
well.
the one thing that you have to recognize is that this quadratic is missing the x term. So I don't really need to solve it the hard way. I can move the 4 over to the other side and solve it by taking the square root of both sides. As long as you remember that plus or minus.
Okay.
Okay? But the moment I put an x term in there, I cannot solve it that way. I now have x squared, x, and a constant. I have to put everything on one side, put 0 on the other side. Now I can solve it.
Okay.
This clearly does not factor. I don't know if you can see that or not. if you factor enough, you'll start so you recognize what does and does not factor. So I wouldn't spend any time at all trying to factor that, and I would go straight into the quadratic formula
Okay.
to solve it.
All right. We pretty much covered most of the stuff.
Yeah,
So let's just go over then, I guess, vertex form and completing the square.
Okay, this is vertex form. And the reason you might want to put a quadratic that is in standard form into vertex form is because you immediately know where its vertex is once you get it into vertex form. So let's take a quadratic. Let's take that last quadratic that I just said I knew didn't solve. Let's put this in vertex format.
Okay.
Okay?
So
Notice that vertex format has everything on the same side. It's all on the right side.
right.
Okay? So all I have to do is set the 4 aside,
Yep.
like that. Put parentheses, group the x squared and the x, and complete the square inside the parentheses.
Okay, yeah, I remember this. So then you take the x and you divide it.
Take its coefficient.
You take its coefficient. Then you square it and add it to.
Take half of the coefficient and square it. And add it inside the parentheses. So in this case, what is that number?
Well, that's kind of confusing because that's 1.
Okay, what's half of 1?
So just 0.5 then.
Okay, leave it in fractions. It's 1/2.
Okay, 1/2.
Now square 1/2.
1/2 squared is 1.
1/2 times 1/2. Remember, when you square numbers that are less than 1, they get smaller. They don't get bigger.
Okay.
Okay? So 1/4 is what I want to add. Always adding.
And
What
then
do I
you
have?
also, you're going to need to subtract 1/4 from the outside.
Okay, now I haven't changed it. But the key thing is now I can write this thing as an x minus h squared. That was the reason I completed the square, was so I could write this as x, and what's the thing you take, what's h going to be? Whatever half of that coefficient was.
Right.
Well, it was 1/2. K now becomes the sum of both of those. Well, now I got it in vertex format. A is 1. The vertex is at where?
Vertex, let's see, will be at negative
No.
1/2.
No.
Wait, no, negative 1/4.
No.
And then, wait, no?
No. H is the first coordinate of the vertex.
Yeah.
Well, what is H here?
Oh, it's negative 1/2.
It's not negative 1/2.
So h will be 1/2.
H is positive 1/2. In other words, the format is x minus h, much like when you're doing translations. When you're doing translations left and right, it's x minus h. Whereas h, if it's positive, you go to the right. If it's negative, you go to the left. Same thing here. It's always going to be x minus h. Even when you get to conic sections, it's x minus h. Okay? So the vertex is where?
Is negative 1, negative 1/4.
No.
And then,
No.
wait.
Positive 1/2. H is the
okay.
x-coordinate
Sorry,
of
I
the
keep
vertex.
looking at the equation above.
Okay, what's K?
Okay, yeah, I knew that. And then 4 1/4.
Negative 4 and 1/4.
Negative 4 1/4.
And that's negative because the
That's
general format is positive k. So when we came up with minus 4 1/4, then k has to be minus 4 1/4.
okay.
So that's the vertex. And now we'd know how to graph it because we put it in vertex format.
Okay.
I wouldn't know how to graph it in the format that it was given to me. X squared minus x minus 4, wouldn't know how to graph that. Once I get it in vertex format, it's quite easy to graph.
Okay.
Now the only thing I wouldn't know how to graph would be the x-intercepts. In other words, I knew the vertex was at 1/2 minus 4 1/4. I know that it opens up, but if I really want to graph it properly, I need to know that right there. Right?
Mm-hmm.
I need 3 points to graph a parabola. And usually the teacher wants those 3 points to be the vertex and the x-intercepts if there are any. Well, how would I solve for the x-intercepts?
Mm.
What is y when you're on an x-intercept equal to?
What is y?
What's the value of
0.
y?
It's
Right.
0.
So the way I solve for the x-intercepts is to
you
take
make
my
y 0.
equation and let it equal 0.
Okay.
In other words, go back up to this expression here and set that equal to 0. Well, to solve that, which is going to solve for my x-intercepts, I'm going to have to use the quadratic formula.
Okay.
That'll give me my 2 values of x, where y is equal to 0. I already know that it's a quadratic. All quadratics are going to look like parabolas. And I know the vertex is down there, but if I really want the x-intercepts, I'm going to have to set it equal to 0 and solve for it, which is something you probably are going to have to do because that would be a pretty good problem. It would encompass a whole bunch of things. It's going to force you to use the quadratic formula. You're going to have to find the vertex, or if you put it in vertex format, you don't have to put it in vertex format to find the vertex. If I said, where's the vertex of this? Perhaps an easier method than putting in it, completing the square, is just knowing that the line of symmetry of the vertex and the x-coordinate is equal to minus b over 2a, the first half of the quadratic formula. Well, in this case, what is that? That is 1/2. So I found the x-coordinate of the vertex almost immediately without completing the square. Where's the y-coordinate of the vertex? Plug this into the equation for x, and you'll get where y is when x is equal to 1/2. In other words, it would be 1/4 minus 1/2 minus 4. That's minus 4 1/4. So it's almost easier to find the vertex by this method than it is by completing the square. But she's liable to say, put it into vertex format and find the vertex. So you need to know how to do this method for sure.
Okay. I think I'm alright on the vertex form as well, because I remember last time we went over it a lot.
What's x equal to here?
The square root of 9.
What is x equal to?
I want to say the square root of 9.
Well, simplify it.
3.
But it's not. It's equal to plus or
Or
minus
minus
3.
3. Okay, darn. I'll write that on the top of my test, I guess, in big writing.
And if you're writing it, I would write it like this on top of your test. Not like that. You might not
Okay.
get what that means. But if you
Yeah.
write it like this, you will not miss it.
Okay. Yeah, I'll make a note of that right now to write it. What was the other
And
thing?
remember that
Completing the square.
it works with imaginary numbers also. In other words, I should have really said this. So what is this?
Square root of -9 or -9 times
Simplify.
or the square root of 9, sorry, times the square root of -1, which is I. So the square root of 9I.
Square root of 9 is not simplified.
Or then, so 3I.
No.
Oh, darn it. Okay. Plus or minus 3I.
Okay. It's really easy to forget when you're dealing with imaginary numbers. Okay.
So I'm just going to probably do that for, I mean, it's pretty much all of them, isn't it?
Every single time you have to solve an equation by taking the square root of both sides, you have plus or minus, always.
Okay. Okay.
Let me give you another one here. Don't solve this, factor it.
These always bug me, like when you have to factor them, because I always want there to be 3 numbers.
Right. That's why this is special, why I put it up there. What I want you to do is recognize what you're looking at. What's it called? It's got its own name. Difference.
Oh, the difference is...
The difference of perfect squares.
Perfect squares.
16x squared is a perfect square, and 81 is a perfect square. So we have the difference of perfect squares. The answer is a minus b times a plus b, where a is the square root of this term and b is the square root of this term. So what is my answer? How does it factor? In other words,
So
here's what I mean. A squared minus b squared is a minus b times a plus b. Always. So here,
okay.
what
So
is a?
4 minus 9, and then
Well,
4 plus
hold on. 4x is the square root of that.
minus 9, and then 4x plus 9.
Okay. Now, notice that when we solve it, what is our solution? If I had set this whole thing equal to 0, so what's our solution?
You set it to 0. What do you mean?
How do you solve it from here? For x.
Oh, I distribute. Or, wait, no.
No, we just undistributed.
Yeah.
What do you do at this point when you're solving a quadratic and you get one thing multiplied by another thing is equal to 0? There's a reason we make 0 on the other side as opposed to a number. If I had this thing multiplied by this thing and it was equal to 1, I couldn't solve it. If it was equal to 3, I couldn't solve it. There's only one thing it can be equal to that allows me to solve it. 0.
0.
Why is that?
Because then you can get the x's alone, or?
No, because if you multiply two numbers together and they're equal to 0, one of them has to be 0. So at this point, I can now say that either 4x minus 9 is equal to 0, or 4x plus 9 is equal to 0. And when I solve it, I get x equals 9/4 or x equals minus 9/4. You with me?
Yep.
Okay. So I know what my two answers are, plus and minus 9/4. Well, there's an easier way to solve this problem rather than factoring it. That's to move the 81 to the other side, make x squared equal 81 over 16, and now take the square root of both sides, plus or minus 9/4. So if I do it this easy way, but I forget to put the plus or minus, I'm going to lose half credit on the problem. If I do it by using the difference of perfect squares, I account for that plus minus automatically.
Okay. Okay.
Factor this.
X squared minus 1.
Solve it by factoring as opposed to solving it by taking the square root of both sides.
Oh, solve it by factoring?
Uh-huh.
Okay then. X minus 1, and then x plus 1.
Right, that's the difference of perfect squares. Even though it's a 1, 1 is a perfect square.
Okay.
So it's x plus 1, x minus 1, which gives you both solutions, x equal plus or minus 1. And if I would have solved it by taking the square root of both sides, I still would have gotten it after moving the 1 to the other side. All right, any last problems?
I think that's it. Trying to look here.
Let me give you one here I'm looking at. This is kind of different. We haven't talked about doing one like this. How would I do this? First of all, there's a couple of ways to do this. Let's do it the easy way. What's the hard way to do this?
Let's see. Hard way would be the square rooting.
No, that's going to be the easy way. That's actually going to be the easy way. The hard way would be to go ahead and multiply that out, FOIL it out, put everything on one side, 0 on the other, and use the quadratic formula.
Okay.
Because it's probably not going to factor nicely, but we don't really know. It's hard to see. Without expanding that, I don't know if it's going to factor nicely or not. But I know it's going to solve really easily by taking the square roots of both sides. So let's do it this way. Take the square root of both sides. What do we got?
Okay. Square root of x plus 4 equals the square root of 1. If 4 is kind of in the way. But
what's the next line of this equation?
or square root of x plus 4 then equals square root of 1.
Okay, so I'm going to take the square root of both sides. Now what?
Oh, what am I missing?
What is left on the left when I take the square root of it?
X and 4.
X plus 4. That's what's on the left. What is on the right?
Just 1. Or square root of 1. Plus or minus square root of 1. 1.
So now what are the two solutions for X?
Well, you would subtract 4 from both sides. So X equals plus or minus 3. Or negative 3.
No, you have to separate it. In other words, we have two equations. When this plus or minus, when you see that, that means X plus 4 equals 1 and X plus 4 equals minus 1. So when we solve for X, we have to do it both ways. Let's start with the plus 1, subtract 4. That's equal to minus 3. And the other thing is the minus 1 minus 4. So that's equal to minus 5. So those are my two solutions.
Okay.
And it was far easier to do this problem by taking the square root of both sides than it would have been to expand this into x squared plus 8x plus 16 equals 1. Then I subtract 1 from both sides, equaling 0, and then hopefully I'll see that that factors into x plus 5 times x plus 3 to give me these two solutions.
Okay.
But what I wanted you to see was this plus or minus, how that affects. In other words, you have to know when you get x plus 4 equals plus or minus 1 how to handle it from there. Just break that into two different things. All right.
All right.
Thomas, good luck on your quiz. I will talk to you next time.
Thank you. And I also might be soon doing 2 lessons a week because I would like to get more ACT lessons in.
That's fine.
Or SAT.
You can schedule it every day of the week as far as I'm concerned.
Okay.
Okay?
Sounds good.
All right, Thomas. All right, bye-bye.
Thank you.